Hi guys, it's me Muhammad Moin. Welcome to my YouTube channel. In this video tutorial, I will be discussing logistic regression. What basically logistic regression is, for which problem statements we can use logistic regression, how logistic regression is different from linear regression, applications of logistic regression. Plus, I am going to discuss a very important thing in this video. Can we use linear regression for classification purpose? You all will be confused now why we are discussing linear regression in logistic regression video tutorial, because the use of logistic regression will be clear to all of you when I will explain why we cannot use linear regression for classification purpose, and how we can use logistic regression for classification purpose, and what are the limitations or issues that we cannot use linear regression for classification purpose, and we have to use logistic regression for classification purpose. So let us start with explaining what is basically logistic regression is. So in simple words, logistic regression is a method for classifying the data in machine learning. So if I have a data, I want to classify it whether it belongs to class A or it belongs to class B. So I will simply use logistic regression. It will classify the data whether it belongs to class A or it belongs to class B by learning from the training data set I provide to it. So I think it's clear what basically logistic regression is. To more clarify, let us further discuss. Logistic regression is a supervised machine learning algorithm that can be used to model the probability of a certain class or event. It is used when the data is linearly separable and output is binary. Let's first clear this point. So logistic regression is basically a supervised machine learning algorithm. What is basically supervised machine learning algorithm? Supervised machine learning algorithms are those algorithms where we have labeled data, and now discuss. Logistic regression is a supervised machine learning algorithm that can be used to model the probability of a certain class or event. So basically, I want to model the probability. If I have a data, for example, I have two classes, class A or B. I want to predict whether which part of the data belongs to class A and which part of the data belongs to class B. It is used when the data is linearly separable and output is binary. So we use logistic regression when we have a data which is linearly separable and output is binary. What does it means by binary? Basically, the binary class itself has two classes. Means it can be output can be yes or no. It can be 0 or 1. It can be true or false. So next point, logistic regression is a method for classifying the data in machine learning. We use logistic regression where we want to classify data in two or more classes. I hope now everything related to logistic regression will be clear. In simple words, we use logistic regression where we want to classify our data either in two or more classes. If one is basically binary class and other is basically multiple class logistic regression. In binary class we have two classes, which is yes, no, true, false, 0 and 1. So basically you can say that logistic regression is a classification algorithm for two categorical variables like yes, no, true, false, 0, 1, etc. So let us move forward and discuss further things. So there are two types of logistic regression. One is simple logistic regression where we have a single independent variable which is used to predict the output. While in multiple logistic regression we have multiple independent variables, means the output variable depends on multiple input variables. In simple logistic regression we have a single input variable on which our output depends. In multiple logistic regression we have multiple input variables on which our output depends basically. So now let us further discuss one important point. What is the difference between linear and logistic regression? You need to clear this, my friends, very clearly. You need to know what is the difference between linear and logistic regression. So guys, listen it carefully. Linear regression is used where we want to generate continuous value. For example, I will use linear regression. In that case, for example, I want to predict the price of the horse. someone incomes in future. For example, I want to predict what would be my manager income in the future by analyzing its previous increment records, all this everything. I can predict the population of a city, of a country in future, after 10 years, after 15 years, what would be the population of my city, my country. While in logistic regression, I only compute the probability. For example, I will be computing the probability whether it will rain or not. So there can be probability between 0 or to 1. For example, there might be the probability of raining 0.7%, or there might be a probability of raining today 0.3%. So basically it lies between 0 and 1. Basically in logistic linear regression, we basically work on continuous value. For example, we basically work on predicting the price of a house, what would the income of a person, what would the population of a country. While in logistic regression, we basically compute the probability whether this thing will happen or whether this thing will happen or not. For example, it will rain or not, he will sold his house or not, he will sold his house, whether Ali will go to school today or not. So that's the difference between linear and logistic regression. Basically, linear regression is used for generating continuous values, while we use logistic regression to compute the probability which lies between 0 and 1. So one thing important, if the probability comes out to be greater than 1, then for example, I want to split my data into two classes, whether it belongs to class A or it belongs to class B. So I'd say if my probability comes of output comes greater than, it becomes, for example, if I predict and my probability comes greater than 0.5, it means it belongs to class A. And if my probability comes less than 0.5, it means it belongs to class B. So this is basically the difference between linear and logistic regression. Now discuss something further. So can we use linear regression for classification purpose? We use logistic regression for classification purpose, but can we use linear regression for classification purpose? That is the point we are going to cover it. If not, what are the limitations that we cannot use linear regression for classification purpose? So let us clear all these things. Let us see if we can use linear regression to solve a binary classification problem. What is basically a binary classification problem is? The binary class basically has two classes which are basically yes, no, true, false, 0 or 1. So assume we have a data that is linearly separable and has the output that is discrete in two classes, whether it belongs to class 1 or it belongs to class 0. Okay, that's fine. So basically we define a threshold that value greater than 0.5, it belongs to class 1, and value less than 0.5, it belongs to class 0. So we have defined a threshold. You can see it clearly over here. So now for example, my predicted output comes 0.2. It means clearly means it belongs to class 0. If my predicted output comes 0.6, it means it belongs to class 1. So we are correctly classifying our data. So is there any problem that might occur? Let us see. So if the predictive value for x1 is 0.2, which is less than the threshold, so x1 belongs to class 0. We have done discussed previously, like here 0.2. If the predictive value for the point x2 is 0.6, which is greater than the threshold, so x2 belongs to class 1. So if we have value over here 0.6, it belongs to class 1. So if it's good, or yes, it's good, yeah, it's over here. So if the predicted value for the point x3 is beyond 1, so if my predicted value exceeds 1, if actually I have a threshold between 0 and 1. If the value is from 0 to 0.5 to 1, it belongs to class 1, and if the value is 0 to 0.5, it belongs to class 0. But what if the value exceeds 1, or if the value goes below 0, then what will happen? Does it belong to any class? No, it doesn't belong to any class. There is an issue here. When the value exceeds 1 and when the predicted value goes below 0, it does not belong to any class. Neither it belongs to class 1 or neither it belongs to class 0. So there is an error. Thus, so this is our first limitation. If our value exceeds the threshold, there is and if the value goes below that threshold, there is an issue. Which class does it belongs? So another definition, if you see, if you introduce an outlier, see what happens. So as you can see, I have my data points over here and over here. I have classified it whether it belongs to class 1 or it belongs to class 0. If an outlier come here, my best fit line will change, my regression lines changes, and my data points are not so these are now data points are wrongly classified, because previously my best fit line was this, the black one, L1. Now my best fit line is this, L2. So when L1 was my best fit line, my these data points are correctly classified. Now because of outlier, my best fit line changes, now it becomes L2. Now these data points are not correctly classified. These are wrongly classified data points. So if an outlier comes, my best fit line changes and my data points or classified points, there comes an issue over them. They might get wrongly classified because of the new best fit line that I am creating because of an outlier. So there are two issues, there are two limitations that we cannot use linear regression for classification purpose. The first limitation is the predicted value may exceed the range 0 and 1. It may goes to beyond 1, it may goes beyond 0. So which class that is belongs? It belongs neither to class 1, it doesn't belong to neither to class 0. Plus my error rate can increase if the data has outliers. So for example, here my error rate increases if I plot the new best fit line and these data points get wrongly classified because of the new best fit line. So these are all my issues. Applications of logistic regression, where we can use logistic regression. We can use logistic regression where we want to predict the probability of a person having a heart attack. For example, we can use logistic regression to predict whether a person will have probability of a person having a heart attack or not. So we can use the logistic regression to predict the probability of a failure of a given process or product, that whether the following process will fail or it will pass. So this is all from logistic regression. Thank you for watching the tutorial. Have a good day. Thank you all. See you all in the next tutorial. Thank you so much.